Advent of code day 2. Run that, run that. Advent of code day 2. Let's get it. Come on. I need to go move fast. Oh, site's going down. No way. Site's getting DDoS. Uh-oh. Uh-oh. Everyone's trying to get on. What the heck? Come on, please, please. This is crazy. The site's getting DDoSed. I need to. So if you the faster you complete it, the more points that you get. So I'm just trying to get this in, but looks like advent of code is down. What the heck? How do you get the downtime? Oh my, wow. Everyone's flooding in. They need to make their servers better. That's sad. That is sad. Advent. Oh, there you go. Let's get it. Now they slowed me down. What the? Okay. So let me move this over here. Cool. Let's get into day 2. Now I'm a little bit behind, about 2 minutes behind due to slow servers, but we live, we move on. Cool. So fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. While the Red Nose Reindeer nuclear fusion fission plant appears to contain no sign of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. So we're still looking for this chief historian. Um, okay, cool. We're checking the nuclear fusion. This probably doesn't even matter. I'm just writing this down. Checking nuclear plant. They're quick to add that since you're already here, they'll really appreciate your help analyzing some unusual data from the Red Nose reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. You offer her to help them with unusual data. The unusual data your puzzle input consists of many reports, one report per line. So each line, like one, let's say input, and we have one report per line. Each report is a list of numbers called levels that are separated by spaces. Okay. So 5 levels each. The engineers are trying to figure out which reports are safe. The Red Nose reactor safety can only tolerate levels that are either gradually increasing or gradually decreasing. So a report only counts as safe if both of the following are true. The levels are either all increasing or all decreasing. Any two adjacent levels differ by at least 1 and at most 3. Okay. So it needs to be strictly increasing, strictly or strictly decreasing. Any two adjacent levels differ by at least 1 and at most 3. So cool. Yeah, okay. I see. I have an idea for how to do this. Reports equals, we take the input array, and then we split by new line. And obviously we skip like the first element and the last element. Python 3, day 2. So we have all the lines here. And now we just say, say, to get the answer. How many reports are safe? Okay, so now we have all these reports. I'm just going to grab the input puzzle. Or let's just run it on this input and just make sure that it's working correctly. So let's do safe reports equals 0, and eventually we print out the safe reports, and we go for report in reports. We grab elements equals report dot split. Or we split by the space. So we're gonna say for I in range, pretty much like from 1 to the length of the elements. So we only care about the first element, and then we're gonna say for I in range elements, we're gonna say safe equals false. So safe is true for now. And then if safe is true by the end of it, if safe equals true, then we do safe plus equals 1. And then we say for I in range elements, what we're going to do is like if safe, if elements dot I so it needs to be strictly increasing or strictly decreasing. So let me just write a function that does that. Yeah. So it's gonna be over in times of like def is increasing. Array. We're gonna say for I in range element of array is and we're gonna say if array I is less than or equal, if the array I is less than equal to array I minus 1, because it needs to be strictly greater than, then we return false. Right. We'll do is decreasing. Then we'll do is decreasing. We'll just flip this. If the array I is greater than equal to, we do that. So let's just quickly test this function. Or we don't have time to do that. Basically, what we're going to do is split. Then we'll say if not is increasing. If it's not increasing and it's not decreasing, or sorry, if it's not decreasing and it's not increasing, then we pretty much just continue to the next report. If it is, then we just need to check that the distance between each of the elements, like it's not a safe report, if this is the case. This is already harder than day 1 by a little bit. Pretty much now we just need to check if it's a report. We pretty much what we do that is if we just need to check if the distance is between like 1 to 3. So we'll say if the absolute difference between the element I, or let's say distance, greater absolute distance of elements I minus elements I minus 1, if the distance is less than, because we differ by at least 1, if it's less than 1 or the distance is greater than 3, then we say safe equals false, and we'll want to break out the loop. Then we'll say this we'll say report, and we'll pass in the safe variable. Cast these do safe. What we're gonna do is we're gonna elements. We're gonna do map lambda x int x, like this. Elements. Turn a list here. So the elements, we're casting all the elements to a list. So safe. What did it do? Sorry. Let's go here. Print elements. Let me remove the print here and the print here. Make sure this print, okay. So we have elements for if the elements is decreasing, safe, okay. So let's just print here, exiting. Print exiting here, and then we'll do this. We'll also print a report. So we'll say, where's this first print statement? Safe equals true. Okay, 76421. Why didn't that count? Oh, sorry. Safe reports. A little bug. Killed about 15 minutes there. So true. Exiting false. Why is this not? Is, oh sorry, is increasing. Save reports. So we get 2. Okay, let's just put in this big output. Let's put in this big 510. Submit. Woo! Gold star, part 2. Took about 15 minutes for that. So the engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now the same rules applies before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. Okay. Let's see. So let's just count the number of errors. 0. And instead, we'll increment the errors here, and we'll return the errors. And then we'll take the errors here. We'll increment the errors here too. So it's either increasing or decreasing, right? So we'll say is increasing. We'll say array increasing equals is increasing. Then we'll take the elements. Less, if that's less than 2. Or yeah, less than 2. So either 1 or 0. Array decreasing equals is decreasing and the elements is less than 2. If array is not increasing and it's not decreasing, like there's more than, like it's none of these are less than 1 or less than 2, then we exit, right? But now we need to count like errors, and let's say increasing errors. If not increasing errors is less than 2, we have decreasing errors. If none of those are true, then return. Then what we're going to take is like the one with the minimum number of errors. Yeah. Because the one with the minimum number of errors is the one that's going to succeed. And then we're going to do errors plus equals 1. If errors is less than 2, right there, and then let's just run this. 6, 7, 8. Why did the number of errors increase? Oh shoot. Is this the different input? Okay, same input. The errors should decrease though. Ah, I see. It's because when we remove the error, when we're checking increasing, we should we should remove that element. We should remove that element. We should remove the level that didn't work. So we'll say if continue, right? Else right? Array.I. Then what we have here is we'll do the same thing here. So it's actually dropped from 510. Continue else. Right? If okay, is increasing absolute if increasing if the length okay, sorry. Let's get like is increasing is increasing errors. So increasing array, decreasing array. If the increasing array at most one, let's see. Let's just return the number of errors here, like we did before. Oh no, we don't even care about the errors. Pretty much we're gonna say if at most one, it is increasing, we pretty much get the element, but we remove any element that's pretty much like not increasing properly. So we'll just return let's just count the fixes. Wait, let's see. Let's see if this is fine. Because if we have to remove multiple, then it's going to cause the array to shrink. Okay, yeah. So we're going to update the array and try to make it safe. Now we're going to check at most one difference equals if the length of the increasing array minus the length of elements, and take the absolute value of that. If the length of these are greater than 1, just to make it work, then we can't increase it. Not increasing. If then we'll do the same thing with decreasing. This took way longer than the last one. Decreasing. if it's not increasing and not decreasing, we just do that. And then we can count the errors, right? If the errors is greater than 1, like we pretty much only have room for one error here. Errors, if there was no errors here, then we're good. Let's count num errors. Yeah, I guess we gotta count errors. Equals 0. Return it here. Then we do errors. 1. We don't really have to continue here. Now we have errors inc, errors decrement. And what we're gonna do is take the minimum of those. If the errors is greater than 1, or if the errors is less than equal to 1, save reports. What? Okay. That's definitely not right. So let's just put it on this smaller input again. And let's see what's breaking. Errors less than. So safe without removing any. Unsafe regardless of which level. Why is that unsafe? If it should have exited here. If not. Print increasing array. Print decreasing array. So this one didn't move anything. So unsafe. So 1, but that's 5 or distance. Oh, because I'm operating. Array to operate on equals we'll use the increasing array if the errors of increasing is less than errors of decreasing. Else, then we'll use a decreasing array. What's going on? If increasing array, else. Why is that true? Why is that true? We're using that. Let's just debug this, right? Okay, we should. Oh, we have to delete the 2 and 7. Yeah. What we'll do is we'll take the elements dot I minus 1 and make it equal to elements, or we'll take the current elements dot I and make it equal to the one below it. That essentially like deletes it. This one is tricky. This one is tricky. This one is tricky. Let's see. Should be lower than 5. This one's. Let's just try 539 quick. Hopefully there's no exponential back off. Okay, 1 minute again. This one is tricky. Got the first. Okay, what am I doing wrong? Let's run the example again. I don't think I'm gonna get any points today because I just went way too slow. Let's just remove a ton of these debugs. The second level. Print elements. Let's see. Well, yeah, there's two cases actually. The first case is I try to delete the one behind me, or I delete myself. Or I'll probably want to make I'll probably want to make myself equal Yeah, I wouldn't want to do this actually. I want to. So 2 7. Only one error here. Why is this saying true? Why is this saying true? Which level is removed? Let's say if the distance is less than 1 or the distance is less than 3i. By at least 1, at most 3. Okay, 127. If I remove, okay, if I remove 2, okay, why does this, oh, I see. Okay, I'm just having trouble with this. It should start with at least 1 error, right? Oh, why is it 0? Why is it increasing? Errors plus equals 1. See. Errors increasing. Did I increase? Errors decreasing. So why is that 0? Seven, 6, 4. What's going on here? So we're saying elements, and we're saying, okay, we're saying elements increasing, decreasing. Why is it 0? Okay, let's just run this here. I don't know why I didn't do this before, but let's do print is increasing. Let's just do a very, very basic example. Let's do Oh, there is 0 because it is increasing. But regardless of which element, if we remove 2, we have a gap here. Why is that the case? Why can't we remove 2 here? Because I guess if we remove 2, then we get, what happens if we remove here? Regardless of which element is removed. Okay, if we remove this one, which one would we make it take? I'm close here. Okay, I'm just gonna make this a little bit more brute force. Okay, wait. I'm getting hit by a specific edge case here. Let me think. Let me drink some water. Why does this get safe? Okay, so if we ignore a value, so it needs to be strictly increasing. And okay, we're checking if it's increasing by ignoring value. We're checking if decreasing it. Then let's do like is. Let's use a stack here. Just use a stack. So for each element in the array, if the array I, so we're checking if it's increasing by a proper amount. So we're gonna put the element on the stack. If the array is less than equal array, and we'll say for element in array 1 to the end, right? So what we're gonna do is like if the element is less than equal to okay, base case. Oh no, we already have something in the stack. But if the element is less than equal to so because we're checking if it's increasing, so if it does that, we kind of want to ignore that element, right? That's kind of like popping it from the stack. Right. But which element do we ignore? Well, since we're looking at two values at a time, we could either ignore the first element or the second element. If we ignore the second element, it might get closer. This, like, it depends on what the third element is. So we kind of have to look at both cases. So we have to look at both cases. Oh, this is a hard question. Not it's more of like getting into the higher level of easy, but you can see I still took 46 minutes to complete it. But what I'm gonna do is I'm gonna track the errors and I'm gonna do the errors starting at 0. That's a if errors if the errors is greater than equal is greater than 1, then we'll just return false. Right. Otherwise, what we're going to do is we're going to calculate the errors, or what we're going to do is, like, for element in R, if the element is less than equal to the last element in the stack, we're going to do we're gonna recursively is increasing. We're gonna do how are we gonna do this? Because we can either remove the first element or the second element. Because at some points, if we remove the first element, that's better off. But sometimes, well, we need to remove one of them to make it right. But if we remove the first element, we can make... It depends on what the third element is. Because if the third element is, like, closer to the first element, then we'll want to use that. If the second element is closer to the first element, then we'll want to keep that. So we don't really have to recursively do this then. If the element now let's just count errors again. So we're gonna say, and let's just like enumerate from array starting from the first element. If the index is equal to the length of the array minus 1, then we continue. Else, we need to figure out which one we want to go with. Or or yeah. We need to figure out which one we're going to go with, which one we're going to push onto the array. So if we have this element, either we're going to like take this element. So like if the element or distance from next. Okay, we'll take the distance, which is the absolute value of like the current element. What do we have? The current element. Sorry, I'm starting to zone out. Current element minus the next element, which is like array index plus 1. Like the current distance from next stack, distance from next, and I'm just making this hacky now because I'm solving this question. So saying if the stack element right here, so if the distance from next is less than the stack distance from next, then what I'm going to do is we're going to take the stack dot pop, and then I'm in the stack, and I'm going to append the current element. Else, I'm not going to append the current element to the stack. And in this other case, we just append. So let's do I don't even know if we need to track the errors no more. So is increasing 1279. Okay, what happened here? If the element is less than equal to stack minus 1, or distance from next is less than 1, or distance from next is greater than 3, or distance from 4 equals element, array element. So we're taking the element and we're going to take the stack, the last element of the stack. Wow, this is getting hard. So 1 is closer to 7. If the current element is, if the distance from the current element to that is less than, so I should have kept 2. Because 2 is closer to 7. So it should have popped out 1, but for some reason I kept 1. So for the 0th element, so we're going to be operating in the array. We have our stack. 0, 1, 2, 3. Which case is this hitting? It should have operated on every. Oh, okay, because we didn't even look at 1. But it should have index 0. If the element is less than equal. Okay. So now we're at 8. So 8, I need to compare with 7, I need to compare with 2. Right? Okay, so I'm at 7. So I need to look at 1 minus 1. Or I need to look at the last 2 elements on the stack. Go like this. It's not really a hard question, just so much edge cases. While the stack is there, maybe at the end I need to use a stack. I don't care the errors. If the we'll say let's try this. Oh shoot. So we're saying distance from the one before, right? While the stack and while the stack, what we're going to do is we're going to take the distance from next. But does this even matter? So we're looking at one element and we're just want to compare it to the top of the stack. Pretty much if it's different. What if we just do stack.pop here? Yeah, to get it to fully increase and not by that. Tried multiple approaches here. I think this one's going to be the best. If the length of stack, what's in the stack? Oh. Seven, eight, nine. Okay, cool. Now let's do this, but decreasing. Greater than equal to that. So 9. Let's do 1, 3, 2, 4, 5. Why isn't it work? Is increasing. Nine, 7. Let's do a Hail Mary. If not, if it's increasing or it's decreasing, do safe reports plus equals 1. If this is below 400, then the algorithm is correct. $5.29. Let's just run it on this. Output. Should it should return correctly here. It's doing some damage on me. I have work in the morning. But this is what it costs to be the boss. Report. Not safe. Safe. Safe, not safe, not safe, safe. This thing is not safe. Let's print out the decreasing array here, because that's the one that it should be. My voice is running out, so I literally have to not talk. So we 864. Okay, I think we might have to save. Why does it say it's safe now? Oh, I need to recalculate the distance from before. Holy crap. Please, 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 please. 537. Okay, wait. If okay, I'm not calculating the bottom of the stack. Do this. These are the bounds check. If the length of the stack is equal to 0, you like pretty much popped off everybody. 529. Then yeah, what we're gonna calculate if this is crazy. What? So if the element minus stack, this is crazy. So see if I broke any test cases here. I think now we just need to care about who to keep. So if I keep myself, so we need to check the distance close. So we kind of need to check who should I keep? Should I keep? Well, if there's an error, I need to keep one or the other. if else, it doesn't really matter. If, then I actually have to think about who I want to keep, myself or somebody else. So much edge case here. So distance. Dang, this is crazy. Already got folded by number 2. Move a single level. Probably might, this might even be a better recursive function. Need to think about this a bit. So I think what I need to do is make sure that we choose the right one when we're removing. Because if we have 1 and 2, who do we delete? If we delete 2, if we like pretend this is 10. If we delete 10, if deleted current element, distance between next element. So we take the element and then we say minus, we say stack -1. If the distance between necks of this one we want to take the one that's closer to the next element. So less than. If the distance between the necks of this element is closer, then pretty much all we need to do is do stack dot pop. Else stack dot. Otherwise we do So much duplicated code. It's crazy. I might only have a couple more attempts in me because I have to go to work tomorrow. Feeling a little bit defeated, but I will try again tomorrow if I can't get this. It's crazy. It should be at least. Let me check my messages quick. Give me 1 second. Just gonna do some responding to some people because I just been off for a whole hour and a half. Okay, what's happening here? If the distance between necks of my current element is less than the one at the stack, then I want to keep my current element. So I'll remove the one at the top of the stack. Yeah, I don't know if I can solve this. I feel like I'm close. See what people are saying. I want hints. I want hints. Give me the hints. Give me the hints. Am I not brute forcing it? This is brute force. So if I brute force it, yeah, I could brute force it. There must be a better solution than brute forcing. Okay, I'm seeing people are just brute forcing it. So what I'm gonna do is I'm gonna pretty much take all the elements. So I'm gonna do, yeah, I'm just gonna brute force this because I gotta sleep. So where was I? Oh, I should have saved my input. Does this show? Did I get any stars? What is this? Okay, I'm gonna just do is increasing. So I'm gonna keep my is increasing. Let me just reverse this all the way to a working solution. This is crazy. How am I gonna do that? I should have been saving. I'm gonna start version controlling this. Now I learned my lesson. So is increasing. Wow, I should have just brute forced it the whole time. I don't know. It's fun. It's good to explore, and I explored. All right, this. What I'm gonna do is like we're always gonna skip one. Skip one element. Okay. Remove index from list in Python. For I and range length of elements, what I'm going to do is I'm going to take we're going to do let's pass in an array here. We're going to take candidate equals, we're going to take the elements, we're going to take a list, and we're going to filter out, we're going to take our elements, we're going to filter out let's say for enumerate so what we're going to do is for index element in enumerate for index element in enumerate elements if index equals I, then we continue, else we check, return, we check. Cool. If the safe report so like removes one element, so we remove one element, and then what we're going to do is like if is increasing the candidate array, then we do safe report equals true. if it, we do safe report equals true, right? Do some hard work and perseverance. What? That's a brute force. So we're taking the elements for iron range. Whoa! Let's go. 5:53. You completed day two. That's crazy. Holy crap. What? That doesn't make sense. They said the input is the same. Oh, because there's going to be more safe reports. I thought it would decrease. Damn. Maybe I had it right at some other point, but I didn't realize. I didn't type it in because I didn't know. And I didn't have to brute force it. Yeah, I explored multiple different solutions. That last one was the brute force. I got work tomorrow. It's 10:40. Hope you'll have a good night and happy advent of coding. We're gonna do this again on tomorrow and just grind it out.